Well, hello again everybody. Well, today we're going to be looking at some hot stuff, and the hot stuff that we're going to be looking at is designed for working with printed circuit boards that use surface mount component. But before we get into that, time for a channel update. Now, some of you have noticed that I haven't been putting out a lot of videos at the moment, and some of you have emailed me just to ask if everything's okay. Well, I'm happy to say, yes, everything's okay at my end. There's absolutely nothing wrong, but I'm very busy at work at the moment, and it's also summertime. So I don't necessarily want to be inside making videos, and you don't want to be inside watching videos. It's summertime, it doesn't last very long, so let's get out there and get some fresh air while we can. I know that some of you have enjoyed watching me fail to repair these two Solutron voltmeters. Unfortunately, because I have been travelling away so much with work at the moment, and at the weekends I've had to attend to other manly duties. So unfortunately I've made absolutely no progress on the Solutrons, haven't even looked at them for the last 3 weeks. All I can say is some of the ICs I've actually ordered from China, a couple of them have now arrived, so we'll maybe go ahead and install them and give it a try in the next few weeks. Well, a few months ago I happened to be browsing aimlessly on Facebook Marketplace, and I couldn't help noticing this JBC soldering iron for sale, and it looked to be in very good condition. Now, I wasn't actually after a JBC soldering iron, but I actually do know that they're very good quality, and I always wanted to just give one a try, and the price was really so low I couldn't refuse it. So I went to see the guy that was selling it, and he mentioned that the reason he had it is that he had thought about starting a little business to do things like iPhone repair or repairing MacBooks, or micro soldering, stuff of that nature, and that's why he had this soldering station. Now, it turns out that he actually bought the soldering station and then very quickly found out that he had no abilities and actually no real interest in doing that type of repair work. So almost immediately after using it for just a couple of times, he did put it up for sale. Now, he also mentioned that he had some other equipment that he also wanted to get rid of, and he said, would I like it? And to be quite honest, the price at which he offered me these two pieces of equipment at, again, I couldn't turn them down. They were about a third of the retail price. So what we've got in this box here, we've got a hot air rework station, and we've also got a hot plate. Now, I'm going to say right up front, I know practically nothing about doing surface mount work. I probably have to change a surface mount IC about once every 2 or 3 years. But I have to say, even though I've got no practical skills or ability in it, it doesn't stop me from being intrigued by the whole process. So I thought what we could do today is we could actually unbox this equipment, because again, the wife's been shouting at me that these boxes are cluttering up the hallway. So let's get these unpacked, have a look at the equipment. Now, I certainly am not going to be doing reviews on any of this equipment, for the simple reason is I'm not really technically competent to give a review. I think it's important that when you watch reviews that you're watching somebody who's got a lot of experience in it. I have very little experience in surface mount technology. When it comes to soldering equipment, there are probably 3 market leading brands that you should be aware of. The first of those, and one which I'm most familiar with, is a brand called Pace, and I actually use a Pace soldering iron on my bench. Another very high class and expensive brand goes by the name of Metcal, and they have some very unique heating technology within their soldering irons and stations. And the JBC station here is what I would call another world-class manufacturer, and manufactures of very high quality equipment aimed very much at the professional rather than the amateur side of the market. Now, the CD-S here is actually designed to be what they would call a precision soldering station, which I think by that they mean it's actually designed for working on very small surface mount components. So I'm sure most of you have seen people like Lewis Rothman. This is the kind of equipment that he would use for repairing things like iPhones and iPads, and just very small technology, anything that uses very small scale surface mount. And having just picked up the handpiece here, one thing that is immediately clear is this thing weighs absolutely nothing. I'd probably almost say this weighs about as much as a pencil. There's absolutely no weight in this at all, no mass, which means you can really be very dexterous when you're actually manipulating it. So this is my Pace, and this is a PS90 handpiece. Now, this is actually classed as being quite a heavy duty soldering iron, so it is designed to be much more powerful than the JBC unit here. And of course the reason that I use this most often is because of the type of equipment that I like to work on. So I like to work on things like valve equipment, so that's got very large and heavyweight components that have an awful lot of mass, and that means you need an awful lot of power to actually heat up some of the solder joints. And you also just need a soldering iron which is physically tough, because it's not unusual, you shouldn't do it but we all do, to actually use the end of the soldering iron as a bit of a pry bar when you're actually trying to unwrap the component legs from something like a radio chassis. So most of what I need a very robust and a heavyweight soldering iron station, and something that can output a lot of power. Now I've got to admit, I'm not exactly sure what the power output of this unit is. I think it might be 80 watts, although I think it's called a PS90. I've got a feeling the maximum output might be 80 watts. Maybe we can check that later because I'm not sure. But the thing that is really obvious is actually comparing the two, well, there's a huge amount of difference. So basically the JBC iron here, it probably weighs about the same as a European field mouse, whereas the actual Pace PS90 handpiece, this probably weighs in at, well, probably just slightly more than a Russian hamster. So yeah, it really is quite a big weight difference. For those of you that aren't conversant in the relative weights of rodents, we've got a scale here, so let's just measure the weight of the Pace handpiece. Trying to take the actual weight of the cable off it just slightly. So that weighs in at 60 grams. So at 60 grams, it is a rather obese Russian hamster. So let's actually just weigh the JBC iron here. And this handpiece, this is a JBC, and it's got the number 210, and again it's their smallest and lightest handpiece. So let's just measure the weight of that. So that weighs in, I'm actually going to say that that's probably about 21 grams. So it literally does weigh half the weight. The reason that that makes a little bit of a difference is because we've got quite a lot of mass concentrated here at the end of the soldering iron. So if we're trying to do a really precision job, if we're trying to manipulate it very carefully, well, you know, once this soldering iron starts moving, it's hard to stop because the weight wants to keep it going. Whereas this has got so little mass here at the end of the tip, it's really easy to manipulate it. And even just picking this up for a few moments, I can really see why they would call this a precision soldering iron. And another difference is the way that these are actually assembled. So we actually can just unclip the actual heating element here from my old Pace unit. So this part here from here to here, that's a heating element. It's got a temperature sensor in here, but the actual tip itself actually just screws into the end of the heating element. Now I would have taken this out to show you, but I'm afraid this tip has actually been in here so long it's actually fused, the two parts have fused together, and I tried to get them out the other day and I'm afraid they've become stuck. Now I have actually wanted to replace this heating element. I mean, I can tell you how good they are. This soldering iron is about 15 years old. It's used every day and it's still on the original heating element, and I think it's probably only had 2 or 3 tips in all those years. These are actually very robust and very, very reliable. So to change the tip on this, you would just undo this little screw here and you pull the tip out and put another one in. Whereas the actual assembly of the JBC iron is actually very different because it's actually used what they call a heating cartridge. Now in theory I think I can just pull this out. So yep, there we have. So if you actually compare the two, you can actually see there's a huge difference. So it's not surprising that the Pace iron here can actually deliver an awful lot more power. So within this little stalk here, we do have a heating element, and we also have the temperature sensing apparatus, much like the Pace, but you can just see it's an awful lot smaller. Now I think that the maximum power output of these heating elements, it is actually relatively small. I think it's around 20 watts. So it's just a fraction of what the big Pace can output here. So I'm really not sure how well these little precision cartridges will do on larger through-hole soldering jobs, but in fairness that isn't what they're actually designed for. Now for all the soldering that I do, I actually use this 2mm, and it's a chisel tip, and I use this for everything, and that does include the very small amount of surface mount work that I do. And of course the reason for that is when your only tool is a hammer, then every problem's a nail, isn't it? Whereas the JCB irons here actually have hundreds of different tips, and I've got to admit I've got no idea what to do with most of them. Now this one is a little bit of a knife blade tip, and again I've got no idea what you do with a knife blade tip, so the first thing that I actually did was I went onto the Kaisertech website and I actually just bought a load more tips. Now I saw that some people use this little tiny hook tip. It's absolutely tiny, I don't know if you can see that. The actual end of here must be less than half a millimetre, just a fraction of a millimetre, and it's actually bent so you can actually, I don't know, get round the back of little surface mount components. But the other two tips that I bought was, again, I actually bought another couple of relatively large chisel tips, and the reason that I bought these two tips is simply because they're closer to my paste soldering iron tip that I use all the time. So I thought that, yeah, that was probably what I was used to using, so I thought I would probably need some of them. I think one of them is a wedge, and I think one of them is, I don't know, would you call it a conical tip? It's got like a little solder bucket on the end which is designed for drag soldering, so I was hoping to give that a go later. So we will actually take a close look at these tips when we actually switch the soldering iron on. Going back to the soldering station itself, it feels absolutely solid. It is very, very robust and quite heavyweight. I'm guessing that we have a very, very substantial amount of copper inside here in the form of a traditional transformer. You can actually see that the actual holder for the soldering iron, it's got what I would call some form of a docking station, hasn't it? And I've got to admit, the whole concept of this, it does concern me slightly, because if I wasn't looking carefully what I was doing, you know, if I was a bit busy, not thinking, I think it might be possible that rather than putting it back into the holster, you could maybe touch it down on top of the screen here, and that would, you know, that would really spoil your day if you was to damage this lovely screen here. Now I think I would actually prefer it if the actual power station part here was separated from the holder, because I prefer to put this out of the way at the back of my bench, because we've only got a relative amount of real estate here and I don't really want this in my face, whereas I would quite like to have the actual holster part. I would like to have that at hand, so I'm not really convinced by combining the two in this type of form factor. Now just underneath the soldering iron dock itself, we've actually got a hole and some flaps. Oh. And if I do poke around inside here, I can actually feel that it's a little bit rough inside. So what we've actually got in there, we've got some steel wool. So when you're actually cleaning the soldering iron tip, all we actually have to do is we stuff it into the hole here, give it a little bit of a wriggle round, and I'm guessing the idea behind the flap is to stop us getting lots of bits of solder balls and stuff everywhere. So that's certainly a good idea to contain it. And then immediately underneath this this holder here, we've actually just got the traditional wet sponge. So I guess we've got the best of both worlds here. We've got the metal wool and we've got sponge. Taking a look at the top of the soldering station, I can see that we've actually got 4 holes for the storage of spare tips, and then immediately underneath that we've got this little hole. There's actually a few holes, and what I would say is kind of almost like a claw shape. Now I understand that the idea behind these is when you've actually been using the soldering iron, obviously these tips get red hot. You wouldn't actually be able to touch them with your fingers to pull them out. So I think the idea is that this is a bit of a claw, and you can put the tip in here, and let's just see, you can pull it, and you pull it and it kind of drops into there. Now immediately, as I said earlier, I would be a little bit worried about this thing maybe falling out of there and landing onto this, and well, that would really ruin your day. So again, I'm not sure if that's a good idea. So when you've actually taken your red hot tip out, it's going to sit there while it cools, and I think the idea is then you can pick up another tip which in theory is going to be cool. You put that in so far by hand, and then I think what you're designed to do, you've got these holes here, and it's just meant to just push them home until they click. So that's how you install and remove tips. But yeah, I'm not entirely convinced by this, to be quite honest. Another interesting feature of our soldering iron here is the actual dock station that it sits in. When we actually install the soldering iron into it, what it actually does, it detects that it's been inserted into the cradle, and it actually powers it down so that it actually goes cool. And I guess the idea behind that is because if it cools down when you're not using it, it probably extends the life of the element. Now as soon as you actually pull it out of its cradle again, this actually heats up. Now apparently this thing will heat back up to its working temperature in about 2 seconds, so that's really quite impressive. Now the operating temperature range of this iron, it's between 90 and 450 degrees. So again, we'll see if we can check that. Taking a look at the back side of our soldering station, we can actually see that the handpiece itself, it plugs in at the back rather than the front, and the actual connector here, it's got some kind of a locking barb on it, so it's not going to easily fall out. We can also see that we've got a USB connector. Apparently that's used to actually change or modify the firmware within the soldering station. And we've also got here what looks like, I don't know, it looks like maybe a network or a telephone connector. I think that's designed to be connected to a fume extraction system, so that again, when you actually remove the soldering iron from its cradle, it'll actually start up a fume extraction system for you. We've also got the mains connector at the back, and that's just a standard 3-pin Euro plug. So as you can see, we've also got this whippy thing here, which is actually some form of cable support. So that's designed to stop the cable from dragging on the desk. Not sure how useful it is, not sure, but we'll have to give that a try. Does seem a little bit strange. I haven't used anything like that before. And the cable itself is very, well, it's super flexible, and I'm pretty sure that is manufactured from silicon, and it's about 1.5 meters in length. Before we start soldering today, let's have a quick look at some other equipment which might not be essential in all circumstances, but certainly it could help. So let's start off with what I've got here, which is just a silicon mat. Now normally I do through-hole soldering, so what you'll find is this board's got some surface mount components on it, but it's also got a lot of through-hole components. So when I actually set this on the bench, it's actually sat off. There's a gap here, so the actual printed circuit board material and the copper, it's not actually in contact with the surface of my bench, which actually means that when we're soldering, the heat isn't going to transfer into my bench and we're not going to burn anything. Whereas when we're doing a surface mount printed circuit board like this one, and this is just a little practice printed circuit board, it does nothing but allows you to practice placing components on it. But if I put this on the bench, you can actually see that the board does sit flat onto my bench here. So if I start to solder things, well, the actual heat is going to transfer through this circuit board, and we might have some large ground planes, and the underside of the board is potentially going to get very hot. Well, if I didn't have this solder mat here, the normal surface of my bench is quite likely to burn. So this is actually a soldering mat. It's actually designed for soldering. It's made from silicon rubber, and this will stand temperatures up to 500 degrees C. Now the other thing I've noticed about this silicon mat is that it's not tacky as such, but the surface, it is grippy, which means that when we start to solder, we're actually less likely to push the board around. Again, my old table surface here, it's actually quite slippy. If you just catch it, the board moves. Whereas if I actually catch this one, yeah, the surface is gripping, it doesn't move around. Now because the components we are dealing with are so tiny, and because they don't have things like through holes to locate them, the actual positioning and the stability of the work surface, I'm guessing it's going to be much more important to us. Now the next thing I'm actually going to mention is the solder itself that we're going to use. Now I'm going to be using a leaded solder. Of course most people in production these days use lead free, and although there are some very good lead free solders around, I've got no doubt, I just think leaded solders are much easier for hobby use, which is what I'm doing here. But regardless of the type of solder you use, I would actually recommend that you purchase something in a smaller diameter. Now in my case, I use this solder wire here, which is about 1.2 millimeters in diameter. And if I just hold this over the pads on the IC, you can actually see that the actual solder wire here, it's actually bigger than the legs of the component and considerably bigger than some of the pads. So what's going to happen is, if I try to solder using this wire, I'm going to dump quite a lot of solder onto the legs of this IC. Now that isn't necessarily a problem. In some occasions it can be advantageous, but what you're going to end up doing is mopping some of that solder away. So sometimes it's better not to dump solder everywhere. So what you might want to do is purchase some soldering wire which is a thinner diameter. So this is what I happen to have in stock at the moment, and the diameter of this soldering wire is about 0.5 millimeters. So it's less than half of the 1.2 millimeter wire that I'm using here. So it means that we can actually much more delicately just place solder on the pads where we want it, as opposed to just flooding lots of solder and creating a lot of solder bridges between all the joints here. Now for very small surface mount components and precision work, you may even choose to use a solder with a diameter that's even smaller than this 0.5mm. So I've actually gone ahead, I've actually ordered some 0.3mm, but unfortunately that hasn't arrived yet, so we're just going to stick with the 0.5 because that's the smallest I have in stock. When we're doing electronic soldering work, it's quite common to use some flux, isn't it? And typically that flux will be contained within the solder wire itself. But what you'll find is when you're actually using these very small diameter soldering wires, and actually just when you're doing surface mount work in general, you are going to need more flux than is typically contained within this wire here. You're going to add some additional flux because it's going to make the whole soldering process go much easier. Now in the past I used to use these little rosin soldering pens, and certainly for occasional use these do seem to work fine. They do the job, but again, depending on the type of work you're doing, or if you plan to be doing a lot of surface mount work, you want to invest in some proper fluxes which are designed for surface mount work. Now I've got a couple here which I'm certainly no expert in, so I've got this one here from MG Chemicals, which is, I think it's quite a sticky flux. So one of the advantages about this is that when you actually put your components on the board is you can actually use the flux as a type of glue, and when you're using something called a hot air rework station, it means that the components aren't going to blow across your board. They're so tiny they just blow away in the slightest breeze, so it's quite handy to use a sticky flux to use as a type of glue. Now I've also got another tube of flux here which is made by Amtech, and I think this is a relatively general purpose flux, but this certainly has some advantages for doing certain types of rework, in that although it's quite a thick flux, when you heat it up it goes very runny, so it can be useful where you have pads immediately underneath. Some surface mount components have heat sinks and pads under them. Now you can't directly get your soldering iron onto those, so you want a flux which is a little bit runny so it will actually run under them. The other thing about these fluxes is that they are no clean fluxes, and again the advantage of that is again where you need your flux to run under the surface of the ICs, that can be difficult to clean away. So in theory these non-clean fluxes, they call them non-clean fluxes, but really you should still try to clean it as best as you can. So I recommend you go away and have a look at fluxes, because it's something you're quite likely going to need. I also did purchase some of this very cheap flux, and I bought this from Amazon the other day because it's sold as soldering paste, but one thing I have found is that this stuff, it's kind of the consistency of shoe polish. It's not very runny, so it's quite difficult to dispense. So if I actually just try and pick some of it up, it comes off in kind of lumps, so if you want to kind of apply it in an area, it's quite difficult to do. So yeah, this one wasn't particularly good. I can see this being useful for doing things like dipping wires into them before you tin them, but it seems just a little bit too thick for general surface mount work. Now unfortunately I certainly don't have enough experience in surface mount work to actually make any recommendations, but just recently I did watch a very good video by SDG Electronics, and that channel's run by Steve. Now he did an absolutely brilliant review of various types of these fluxes here, and he compared some very expensive ones and some very cheap ones. Now I found Steve's video on these soldering fluxes actually incredibly useful, so for that purpose I'll actually put a link in the channel so you can go and look at the videos yourself. And on the SDG Electronics channel you're going to find quite a lot of videos about soldering and soldering equipment. Certainly Steve has a really scientific mind, and he's really great at presenting the information to you, so this channel is very much and well worth a watch. For the purpose of just experimenting today, I've gone ahead and I've bought some of these Smd kits. Now these are specifically designed for practicing on, so let's just tip out some surface mount components, and again maybe we'll take a closer look at them later. Oh, I've just noticed I actually got the same kits here as I must have purchased previously. One of the things that I like about this little practice kit is that it comes with a leaflet here, and it tells you about all the various components, because all these different packages of capacitors, resistors, they actually all have their own names for these various packages. So just looking at the resistors here, we've got 1206, 0805, 063 and 042. Now 1206, these are actually the very largest resistors which you will find on a surface mount board, or typically they're the largest. There is ones that are actually larger specialist packages, but typically 1206 is probably the largest you will generally see. And then we've got at the other end of the scale, we've got the packages here which are 0402, which, well, to be quite honest, they're only slightly bigger than a couple of grains of salt. So we've got our largest 1206 resistor package, and then underneath it I've got my smallest 0402 package. Now you can see there's a huge difference in them, and well, this is a needle tip point, so you can actually see quite how small that resistor is. And then over here we've got a CMOS CD-4017, so that's a SOP16 package. Under that we've got an NE55 timer, and that's in a SOP8 package. And then finally at the bottom here, still in their packaging material, we've actually got a few transistors, and these transistors are called SOT23 package styles. Let me just unpack one of these transistors for you so you can take a closer look. Oh, it's just pinged across the bench. Let's grab that. So there you go, here's our SOT23 transistor. Now one thing you've just noticed, that I'm actually using tweezers here. You really are going to need to purchase a set of tweezers because these components are so small. You're going to have a great deal of difficulty handling them without tweezers. So for example, if I was trying to pick up this little resistor here, which is almost as small as the end of the tweezers here, I can't pick it up. It's like trying to pick up a grain of salt. I can stick it to my finger, but yeah, that's not the way to do it. It's just far too small. So you are going to have to invest in some tweezers. So these are the surface mount tweezers that I use, and these are manufactured by a company, and the name of that company is Lindstrom. Now I have to say that these tweezers are relatively expensive, but my advice is to go ahead and purchase the very best quality tweezers that you can actually afford. In the past I did go on Amazon and eBay and I bought very low cost tweezers. They just didn't work out for me. The actual quality of the machining and the grinding, they're just not precise enough to actually manipulate and work with very small components like these. So really, purchase the best tweezers that you can afford. Now there's kind of another unwritten and very golden rule in surface mount electronics, and that's never ask to borrow somebody else's tweezers. Somebody who does surface mount work, they're more likely to let you have a go on their wife than they are to lend you the tweezers, because they are so easily damaged. If you drop these on the floor, chances are you're going to bend or deform the ends of them, and then they're going to be useless. So don't ask to borrow tweezers. Definitely make a point of buying your own. There's two styles that I would recommend you get. These are kind of the parallel straight type. These will probably do about, I don't know, about 80% of the work that you need to do. Although I have to admit, I actually prefer this type of tweezer. These are actually, you can see these are bent at 45 degrees, because these just make it a little bit easier to actually, well, to get your fingers and your wrist at the right angle. Whereas when you're using these, you might have to work with them quite vertically. That's not always very comfortable. It's much easier to work with these tweezers which are actually slightly bent like this. It's just easier to work with, and in some applications you'll find you have to use a bent pair of tweezers because it's the only thing you'll get into a little space, where in some applications the only thing you'll get in is a pair of straight tweezers. So you need to get a couple of pairs. I'm sure you've heard the phrase that cleanliness is next to godliness. That's especially true when it comes to surface mount work. So when you're working on PCBs, if you get a kit, try to assemble it as quickly as possible rather than leaving it for a few years, because what you'll find is all the pads will start to oxidize. That might make the soldering process more difficult. Regardless of the type or age of the board, one thing you want to do is give it a very good clean. You want to clean the board, remove all the fingerprint grease and any contaminants from the surface of the board. That will make it much easier to solder, and really the same can be said of the components. Now what I'm really saying is, if we use tweezers here, we're not going to be handling these components with our fingers, so we're not going to get the legs of these components contaminated, dirty or greasy. Again, the soldering process will go easier if we keep things clean. While we're talking about cleanliness, it's not just the circuit boards that we need to keep clean. We actually need to think of our own safety, because you'll find that there are quite a lot of chemicals that we've got on the bench here. We've got various types of fluxes, also got some solder paste here, which is known to be quite toxic, as well as just the typical lead solders. Now, any type of chemical exposure is bad news, so I would actually recommend that you wash your hands before and after doing any soldering. So of course we want to wash our hands beforehand because we don't want to get the board covered in grease, and we want to wash our hands afterwards because we don't want to be eating and drinking or get these chemicals absorbed into the skin. We're about 30 minutes into this video and I've not even switched the soldering iron on yet, so let's go ahead and do that. And the first thing that happens is the screen lights up with the letters JCB. I can see that the soldering iron is warming up, but it says that it's in hibernation mode at the moment, so the temperature has been set back to, I think that says 45 degrees. Now I know that you can go into the menus and you can adjust that. I think a lot of people have the setback temperature set to about 100. So what will happen is when we take the soldering iron out of the cradle here, it'll actually go up to its working temperature. I wonder if we can modify the temperature while it's in its hibernation state. Well, it looks like we can, so at the moment it's set to 420. That sounds a little bit high to me, doesn't it? Let's just back that down. Maybe we'll start with something around 450 or even 350. Let's see how rapidly the soldering iron can wake up from the hibernation state and heat up to the set 350 degrees temperature. So are you ready? Here we go. Okay, 1 second, 2 seconds, 3 seconds, and we're actually melting solder there. I'm actually burning off some flux or some coating. These are brand new tips, haven't been used before. And having pleasured myself on this stainless steel wool tip cleaner, let's give the soldering iron a go. Okay, so that does look pretty clean. Let's have a go on the sponge. And we can see that the soldering iron temperature, it does actually ramp down really quickly. I'm guessing that's because the iron itself, the element and the actual bit on the end of it, they're really small, so they don't have a huge amount of thermal mass there. So it certainly is very responsive to temperature change. Let's just pull it out of its holster again and watch the temperature increase. So again, from about 100 degrees to 350, again that was no more than a couple of seconds. Now interestingly enough, we can also see it's got this little power level reading here. At the moment with the iron in free space, it looks as though it's using about 9% or between 9 and 10% of its power. I suppose if we try to melt some solder, that actually should increase quite a lot. Now to start off with, I thought we could give it a try with this quite large circuit board. This is a 4-layer circuit board and it has got a mixture of both surface mount components, but it's also got some through hole, and some of the terminals on these through holes, some of the pins are actually relatively large, so I'd actually be interested to see if our precision iron is actually capable of melting some of these solder joints. So let's give it a try. Well, I've got to admit it is actually taking a couple of seconds there, but these are quite large connectors that I'm soldering. They've got a lot of thermal mass. Now I'm just looking at the actual power meter on the soldering iron and it seems to be peaking at about 40% there. I've got quite a large piece of sheet brass here. Let's see how much power we can coax from the iron, and will it actually... Oh god, yeah, it's got no problem doing that. Yep, it does that easily. Again, we're only using about 45% of the iron's actual available capacity. I'm going to repeat that test using my heavy duty paste soldering station. Okay, well I can just tell by the feel of it, the actual paste station here, it's much more powerful and it heats up this joints much quicker. And I think the reason it's doing that is because we've got a lot more thermal mass. And again, the paste soldering station is much faster when it comes to just tinning this sheet of brass. However, let's not judge our JBC iron here unfairly. This is a precision iron for doing micro, very small parts, but we've actually seen it can actually solder some quite hefty through-hole components, even though it's very many times smaller than the paste iron that you can see next to it. Now what I think was quite impressive there, even though this iron doesn't have a whole lot of thermal mass, it has a tiny amount compared with the paste, what it was actually able to do, it could detect that the temperature was dropping, and we could see that it very quickly, pretty much instantly, it actually started pumping more energy into the tip of our iron here to actually increase the temperature and get those joints melted. So I actually think that is a positive test, quite impressive. I've got the iron's temperature set to 350 degrees, whereas our thermocouple probe is indicating 330. Just for giggles, let's check the pace. Now, interestingly enough, my pace soldering iron is clearly on the high side because we've got it set to the same 350 degrees, but it's actually measuring 390. So I've learnt something today. My pace iron is clearly running hotter than the temperature indicated. Going back to the JBC iron, we've actually got quite a number of menus we can look at. So we've got reset and settings, station settings, tool settings, really quite a lot of things we can choose from here. I'm not going to look at the menus today. Basically, the only thing that I'm interested in is just increasing or reducing the temperature of the iron. So just pressing the up button, I can see that it actually increases in 5-degree implements, and the same for reducing the temperature. Now, I think you've also got some buttons which are side to side. Now, I think you can actually use them to store a number of presets. Let me try that. Okay, selecting work temp, 350, 400. Okay, so it's got some presets at the moment of 200, 250, 300, 350 and 400 and 450. But I think what you can actually do is if you've got certain jobs, you can actually program the iron. So rather than having to increase the temperature in increments, you can just go to a temperature preset. Well, as you can see, having last week given Andenstar a right old reaming over the quality of their microscope stand here, you can actually see that I'm going to have a go with it today. Now, I've taken our surface mount components, starting with our resistors, and you can see that I've actually got them at the moment on top of a 1p piece. So just starting at the left hand side, we've got a resistor here, and this is 1206 size. Next to that we've got an 805, then an 0603. But the resistor that I'm most afraid of is this 0402 here, because it is absolutely tiny. As I said earlier, I suspect that this is about the same size as a grain of salt. It is tiny. Now, I actually thought that I've got quite steady hands, but you can see I'm just holding the tweezers here above the actual penny piece, and I'm actually shaking. It's not so bad if I actually touch them to the surface, but yeah, I don't know if I'm going to be able to do that. And then just for a size comparison here, we can see that I've got a standard through hull, and that's a 1/4 watt resistor. So you can actually see the size comparison being placed on top of a 1p piece and this 1/4 watt resistor. I'm going to start off with the 1206 resistor, and first of all I'm going to put just a little blob of solder on top of this pad. And let's just see if I can place that. Well, as a first attempt, I don't think that's great. The actual surface of the solder doesn't look particularly good, and we can also see that the pad on the left hand side, the actual resistor, is sat cocked up in the air. It's sat proud of it. So yeah, that's not a good job there. Now, apart from the placement of the resistor, the solder joint itself doesn't look particularly smooth, does it? That's not good. So I'm guessing I'm maybe not at quite the right temperature, or maybe I've not got enough flux. I've increased the temperature by 10 degrees and I'm just going to attempt to rework it. I'm not sure, am I too high in temperature or too low? Or have I not got enough flux? Maybe let's try a few more degrees higher. Well, I think rather than continuing to mess with that one, let's try placing another resistor. Well, I've been having a practice with these 1206 style of resistors, so let's see how I did. So that's the first joint that I did, resistor R1, and I think it's probably a little bit messy. I think R2 looks a lot better there. R2's not bad, maybe just off to one side. I also don't think that R3 is bad, although it's slightly cocked to one side. R4, I placed it a bit low. R5, I think it's probably not bad. R6, it's cocked to one side, and I think I've got too much solder there. not bad, but I think again too much solder. I think the right hand side of R8 looks really quite good, but the left hand side not so good. R9, again I think the right hand side looks good and the left hand side not so good. Maybe this is just a factor of me being left and right handed and having to reach over the component. I suspect that's got a lot to do with it, and just basically my inexperience. Now I think there is a little bit of a theme going on here, that you can see that my solder control isn't very good. I think I'm putting far too much solder on the joint. That could be because I'm using 0.5mm solder. Maybe I would do better with some 0.3 or something like that, but I don't have any. Let's take a look at the resistors from the side. Now you can see the first one, R1, it's cocked off to one side, we knew about that. R2 looks okay. R3, again too much solder on the right hand side of it, the left hand side's not too bad. R4, same story, too much solder. R5, too much solder on the right hand side. R6, too much solder on both sides. R7, too much solder on the right hand side. Yeah, you can see there's a bit of a theme going on here, can't you? So some of the solder joints look really quite bright, like mirrors, and some of them are a little bit duller. Now I was certainly having some problems getting my temperatures dialed in, and I didn't make a point of telling you what my temperatures were, because to some extent they're pretty irrelevant, because it's all down to the tip you're using, the size of the component, the boards. So whatever I tell you my temperature, it really wouldn't mean anything to you. The correct temperature is the one that works best. Now I was ramping up and ramping down, and in fact I did actually spend a little bit of time here. I actually stopped soldering just trying to find the correct temperature, and I think I went from about 300 degrees all the way to about 400 degrees, and I actually settled on quite a low temperature. So you can actually see that maybe this row of diode pads, the top row of pads, maybe D13, D12, D13, D14, D15, they're all pretty shiny. So I think they were actually done with the temperature of the iron set relatively low, lower than I would have expected. I think it was actually set about 330. Now we also had some rather low temperature measurements when we were using the thermocouple probe. So I don't know if those thermocouple measurements were accurate or not, but I would have thought that around 340 degrees was a little bit on the low side, but it seemed to give quite good joints. Now you can maybe also see, let me just move over again, you can actually see that, for example, on these pads where we've got C1, C2, the left hand solder joint looks really good and the right hand ones are really poor. Now it actually took me a few moments to figure out what was going on there, because I actually soldered all the pads. The ones on the right hand side I did as a column, and the one on the left hand side I did as a column. So what I'd actually done is I'd accidentally picked up the wrong type of solder. So you can see that the pads on the left, they're soldered with leaded solder, whereas the pads on the right, they're actually soldered with lead free. And you can actually see that the lead free is just nowhere near as shiny, and I'm sure I probably had the wrong temperature profile. Now you can see that this board appears to be like covered in these little particles. Well, I think these probably came from when I was actually cleaning the board. I used a piece of tissue and some IPA. Well, it looks like all the fibres from that tissue, they just kind of got everywhere and got stuck to the residue of flux. So I did find that quite messy. Now in fact I found the whole soldering process really quite messy. I'm sure it comes with experience, but my hands were covered in flux. I was stuck to the tweezers, there was flux on the buttons for the temperature control of the soldering iron, even the cap was stuck to the skirting board, there was just flux everywhere. So yeah, a bit more practice is required. I said at the start of this video I wasn't going to do a review of this JBC iron is because I'm not really very experienced for the type of soldering that this is designed for, and as you can see I've got a lot to learn when it comes to surface mount technology, but I think I can have a view on it, and so far I'm sure it's actually very good at soldering, but I have to say I really don't like the form factor of it, and if it wasn't for the fact that I'd bought this relatively cheaply I wouldn't spend the money on it, I really wouldn't. Now there's a lot of little minor things which I just don't like about it. I think the biggest bugbear is the fact that the actual cradle here is actually combined into the unit itself. Some people would say that that saves space on the bench. I totally disagree with that. It just takes up space on the bench, because if the cradle is separate for the base unit, what that means is I can actually push the base unit out of the way. You shouldn't really need to adjust your temperatures very frequently. So really what I want to get access to is the cradle here. So I want the cradle next to where I'm working. I want to stick the base unit at the back of the bench. I don't think you gain anything by combining the two. The other thing that I absolutely hate is it takes me a lot more concentration, because every time I have to put the soldering iron back into its cradle here, I actually have to concentrate on that process. I'm concentrating about not dropping solder on the screen or the buttons, and yeah, I mean, it worries me every time. The other thing that I don't like is the cradle itself is a relatively tight fit around the iron, so every time you want to put the iron into the cradle, it's somewhat like trying to dock to the European Space Station. I actually want to be able to do this blindfold. I want to be able to put it in, just throw it in, but I actually have to think about that and again avoid the screen. It's just a level of worry that I absolutely don't need. Another bugbear I have with the JBC is the storage of these tip cartridges, in that they actually stick up quite a long way from the top of the unit, and because this is a micro or a precision soldering station, the bits are very small and they're actually sharp. So within about 5 minutes of putting this on the bench next to where I was working, I actually had to reach over it to grab something. So what I did, I reached over it like that. In fact, I've just done it again, I've just caught them, but I actually cut my wrist open here on these because they stick up a long way from the unit and they're sharp. If you're going to store these in here, what they should have actually done is they should have made these much more recessed so they didn't stick up so far. Okay, you could put them that way up, that's blunt, but now I don't know what they are, so I actually have to put them the other way up. Another thing that I don't like about the soldering station is actually removing the tip cartridges using these claws here, because what I've found is, one thing, you actually have to hold the station down when you do it because they are quite firmly installed, and you've got to tug relatively hard to get these tips out. But what I've found, in probably 1 time in 10 when you do that, you'll pull a bit hard, and rather than resting or falling into here, because again they don't drop in very deeply, they're almost sat too high, what will actually happen is they'll fall out and they'll land on here, land on the buttons, something like that. It just stands too much chance of tipping forward. It's going to work perfectly now, isn't it? But there we go. You see, that happens, and now you've got a red hot bit at a few hundred degrees. It's either sat on top of the soldering station or it's now just fallen into my carpet slippers. Not good. The lighting that I have in my workshop is relatively bright, but one thing I have also found is the actual contrast of the display and the visibility of it. It is relatively poor, especially in here. Another thing that, again, I'm afraid I don't like about it is that when you actually want to change the temperature, well, you put the up and down button here, I get 3 lines of garbage, and then it actually tells me the temperature here at the bottom. I don't want 3 lines of garbage. I don't want to know what day of the week it is or what I'm having for dinner. I don't want to know what the temperature was. I want to know what the temperature is that I'm actually setting. So the setting temperature here, it should fill the entire screen. I don't want to be reading stuff. I just want to set the bloody temperature. It's as though the person that designed it never tried to use it. Maybe that's the problem, that these things are being designed by graphic designers and artists rather than people who actually have to do some soldering. Generally, I think the quality is really good. I do quite like this little tip cleaner here, although the wire is starting to escape. The sponge is also useful, you know, very basic thing, but it works well. So yeah, I like the tip cleaning stuff. I'm not sure about this little wobbly thing here, which is designed to keep the wire out of the way. Don't really think it does anything particularly useful. Talking about the quality, other people have reported this. I had this on the bench for about 5 minutes, and the first thing that happened is one of the rubber feet fell off it. Apparently that's a common problem with these. Well, it's also a problem with this one, that the bloody rubber feet fall off it. But the rest of the construction is absolutely solid, and I don't think I would hesitate in actually buying more JBC equipment. I just wouldn't buy this form factor. I think it's a terrible idea. So in wrapping it up for today, I'm going to give our JBC Precision Station, I'm actually going to give it a 6 out of 10. I've got no doubt that it's actually brilliant at soldering for the job it's designed for, but the form factor itself has just got too many compromises. Of course, I'm not the type of user that this system is designed for, because I don't do an awful lot of surface mount. Now I guess much like the Andenstar microscope, that JBC, they're not going to be reaching out to me anytime soon with an offer to review more of their equipment. But one thing I always like to say, I'm not paid by anybody to make these videos. I purchased the JBC with my own money, so you get my honest opinion about it. You may disagree. If you do, leave it in the comments. It's part of the fun. But I think for today that'll do. But don't forget to join me next time, where we're going to be continuing our look at hot stuff. So we're going to be having a look at a hot plate, we're going to be having a look at a hot air rework station, and I'm also going to be practicing placing some more resistors, some of those smaller resistors and some of those IC packages. So why don't you join me then? Until next time, bye bye for now.